To see you were able to find this video. I'd also be glad to hear from you. Let me know what you want to see or what you're having trouble with so that I can make content that's useful and meaningful to you. With that said, let's jump right in, shall we? So our previous video was the practice portion of our brackets module. So what we did is we walked through the examples from the Tuesday lecture video, where we went ahead and walked through the examples so that way you could actually see and follow through how you should be solving equations when there are brackets involved. Today's video is the lecture portion of the exponents module. So now we're going to be looking at exponents within the orders of operations. And if we can remember our acronym BEDMIS, brackets exponents, that is our E. So the second thing you want to do when you're looking at an equation is to check to see if there are any exponents. So let's go ahead and start looking at how do you actually handle an exponent. So just a quick reminder for everybody so we know what an exponent is. An exponent is that little number that appears above a number. So exponents are the second operation solved in the order of operations. Like I mentioned, it's the E in BEDMIS. And exponents are basically just saying that you're taking the base number and multiplying it by itself however many times the exponent is there. That's a little bit confusing, so let's go ahead and look at an example. So here we have 2 to the power of 3. So our exponent is 3, and our base number is 2. So what this is actually saying is we're going to multiply 2 by itself 3 times. So we can go ahead and write 2 times 2 times 2. And we're going to put it in brackets because we want to make sure that we solve this first before we start moving on to something else. So you can expand out 2 to the power of 3 to equal 2 times 2 times 2. And just like when you solve any other operation, you're going to look within your brackets and solve the first thing first and work your way through. So you're going to go 2 times 2 is 4, and then 4 times 2 is 8. So 2 to the power of 3 equals 8. Okay, so negative exponents. Sometimes you're going to have a number attached to a base, so you're an actual exponent, that is actually negative. It'll be negative 3, for example. And so what this means is that you're doing the opposite of what a positive exponent is. So you're dividing the base number by itself with the frequency of the exponent. Again, this is a little confusing, so let's go ahead and look at an example. So here we have 3 to the exponent negative 2. So our base number is 3, and our exponent number is negative 2. Therefore, we're going to divide 3 by itself twice. So we have 1 divided by 3 because we're dividing it by itself. That gives us, we do the first operation first, so that's 0.33, and then we do the second part of the operation, and that'd be 0.11. And again, you can put this in brackets if there was more to the equation, if we were actually just subbing in what 3 to the power of negative 2 is. So our final answer of what 3 to the power of negative 2 is 0.11. Okay, now I didn't spend too much time talking about how you solve a negative exponent because that way does not work well for me, and I find it very confusing for people who are trying to learn it. So a faster, easier way that just people tend to pick up a little more easily is to get the reciprocal before you go ahead and solve it. So b to the power of a negative exponent is actually the equivalent of saying 1 divided by b over e. So b being our base number and our exponent being the little number above it. The reciprocal means to flip it. So that makes the number positive. So here we can go ahead and look again. We have 3 to the power of negative 2. 3 is our base, and our exponent is negative 2, so therefore we're dividing 3 by itself twice. So here we're going to just go ahead and flip it. We're going to make the equation positive first, because positive numbers are just easier to work with. So we're automatically just going to put 1 divided by 3. That makes it positive. Allows us to convert the negative exponent into a positive exponent, so now we have a positive 2. And then we can go ahead and substitute in what our exponent would be. So 3 to the power of 2 means we're multiplying 3 by itself twice. So this way we're working with positive numbers rather than negative numbers. So now we have 1 divided by 3 times 3. 3 times 3 is equal to 9. 1 divided by 9 is equal to 0.11. So we're getting the same number. They're just different ways of going ahead and solving the equation. This way seems to work better for most people. The first thing you want to do is to set your equation to be positive. So we're changing the negative exponent to a positive by dividing it by 1. And then making the exponent positive. And then we're expanding how you actually solve the exponents. We're saying 3 times 3 in this case. And then once you solve the multiplication, then you're dividing it by 1 to get your final answer. So here, let's go through another example. We have 4 to the power of 3. So first we want to identify what our base is and what our exponent is. Our base is 4 and our exponent is 3. This means we are taking the base number 4 and multiplying it by itself 3 times. So it's 4 times 4 times 4. Now we go ahead and we solve the first thing first. 4 times 4 is equal to 16, and we drop the rest. 16 times 4 is equal to 64. So this gives us a final answer of 64. Let's go ahead and look at another example. Here we have a negative 3 to the exponent 2. So here we have a negative number, but the exponent is not negative. So we don't have to convert it to be positive. We don't have to divide it by 1. What we're saying is we're taking the base number, negative 3, and multiplying it by itself twice. So what we're saying is negative 3 times negative 3. Now, a negative times a negative is equal to a positive, and 3 times 3 is 9, so our final answer is 9. Now remember, you're only needing to divide by the reciprocal if the exponent is negative, not the base number. If the base number is negative, we just go ahead and multiply it by itself however many times the exponent is. It's only when the exponent is negative. Let's look at example F. Here, this looks a little bit more tricky, but we're only solving one operation at a time. So we start off by looking for brackets. Are there any brackets? Yes, there are brackets and they're within our exponent. So we're going to go ahead and start over again. Are there any other brackets? As we go in, we can see that there is. We have a positive 2. Let me just turn on my little pointer here. So if we look in here, we have a 2 plus an opening bracket negative 4. What we want to do is expand that out. We want to say positive and a negative converts into a negative, so we can actually go ahead and say negative 4. So now we've cleaned up these inside brackets, and we can go ahead and we can look at the outside brackets. We have a new equation of 3 to negative 2, and then we have another set of brackets. Again, we always solve the brackets first, so 2 minus 4 gets converted down to negative 2, because that's the remainder. And now if we look at our new equation, again, we're still working in the exponents. We have a negative 2 with an opening bracket of negative 2. Going back to the brackets video, that means we have to expand. That means we're taking negative 2 and multiplying it by the contents of the bracket, which in this case is negative 2. So negative 2 times negative 2, we're multiplying two negatives. Negative times a negative converts into a positive, and then 2 times 2 is equal to 4. Okay, so now we have just a clean exponent. We have a base and we have an exponent. Our exponent is positive, so there's no reciprocal. We don't have to flip it to make it positive because it already is. So we can say 3 times itself 4 times. So let's go ahead and expand that out. We now have 3 times 3 times 3 times 3. So now we go ahead and we solve the first operation first. So 3 times 3 is equal to 9, and we drop the rest of the equation. Now we can go 9 times 3 is equal to 27, and again, we drop the rest of the equation. Now, all we have to do is the last operation. 27 times 3 is equal to 81. There's no further operation, so we can say that our final answer is 81. So this one was a little bit more tricky, and only in the sense that we had the brackets within the exponents. But the key is, if we always go back to our acronym, you always start with the brackets. You will always look to see, are there any brackets? And if there are brackets, you do them first. When you have solved the brackets, or as far as you can with the brackets, you start to look for exponents. And in this case, we do have an exponent. When we get to our exponent, we start over again. Are there any brackets? In this case, we did have brackets. And so you start the process over again until you've solved out the exponent and you can go ahead and move on to the next step. So remember, adding more to your equation does not make it harder. It just makes it longer. The key is to have an understanding of how you handle each of the different elements of the operations, and then it's just a matter of working your way through it. So, expanding an exponent is multiplying the base by itself as many times as the exponent. So again, if we look at an example, let's take 3 to the power of 4. The base is the number at the big number, and then the exponent is the smaller number that's above it. Sometimes you're going to have a negative number as your exponent. If the exponent is negative, you want to flip it and make it positive first. So you're going to do the reciprocal, which means you're putting it over 1. So in this case, in our example, it would be 1 divided by 3, and then the exponent of 4. Then you can go ahead and solve just the exponent part and then divide it by 1 at the end. So making it positive seems to be easier for people, but it will give you the same answer either way. You still need to divide it by 1 to get the reciprocal value anyway. So it's just it seems to be easier. Remember to make it positive first and then do the multiplication. You also have to remember to keep track of your signs. You're only needing to make it positive, you're only flipping into the reciprocal when the exponent is negative. If the base number is negative, it doesn't matter. You're just going to multiply it by itself, but you need to remember to keep the negative sign associated with the base. If it's negative 2 to the power of 2, you are multiplying negative 2 times negative 2. Right? That's going to give you a positive number, and if it was a negative 2 to the power of 3, it's going to give you a negative number. So it's very important that you remember to bring your sign with your base. Exponents are the second operation in the order of operations. So you start off looking, are there any brackets? And if you've solved all the brackets as far as you can go, then you look to see, are there any exponents? If you find an exponent, you start over. Are there any brackets associated with my exponent? And if there is, again, you start over. You start solving, are there any child brackets? Always working from the innermost bracket, working your way out, and expanding your exponent so that way you're actually able to do the math. Because sometimes your exponent will be large and you'll have trouble just doing it in your head. You can just do it in a calculator if you have a calculator, but these examples I'm trying to give them to you in a way that you can actually practice them and do them by hand. If a base number has a string of operations as its exponent starts, then you start over with a bed mess. Yeah, so right, if you have an equation or another set of brackets or any kind of line that's associated with your exponent, you have to solve that before you can actually start expanding it. It's easier to simplify the exponent and then try to multiply it, because in theory you could multiply it by itself and it's way easier. Make sure you keep your lines as simple and clean as you can. So here are your practice examples. We have a few where there are operations that are associated with the exponent. There are some where the base is negative, when the exponent is negative, and when the base is positive or the exponent is positive. So I'm trying to give you an example of all of the different combinations. But remember, you only have to flip into a reciprocal if the exponent is negative, not the base. So in this example, in B, what we're saying is we have to make sure we divide it, flip it into the reciprocal, so it would be 1 divided by 3, and then 3 times itself 3 times, because it's the power of 3. You don't have to do that for, like, let's say F, where it's negative 2 to the power of 2. Negative 2 times the power of 2 means we're multiplying 2 by its negative 2 by itself twice. Remember to bring the negative sign with the base. If you lose that, you're going to get a wrong answer. Okay, so we're going to take up the examples on Thursday. So it gives you all of Wednesday to go through it. If you're having any problems, let me know. The biggest issue people tend to have with exponents specifically is the whole negative exponent. How do you handle that? So if you have any problems with that or anything else, please let me know and I'll give you some more examples and we can walk through that in a little bit more detail. Because really that's the tricky part with exponents. It's really knowing how to expand it out. And positive ones are pretty easy to expand out, but the negative ones can be a little bit more tricky. You know I love to hear from you, so if you have any questions or any future topic ideas, let me know. Reach out to me in whatever means suits you best, and I look forward to seeing you at the next video.